Hello, everyone. Today we will be learning about classifying real numbers. Please go ahead and make sure that you have this slide open so that you can follow along with the video and fill in your slides as we move along. Okay, so these slides will be found in the Google Classroom under the Unit 1 section at the bottom of the page. Before we get started, I wanted to share this little exciting video with you guys. Let's go ahead and watch this.
Natural numbers are naturally numbers you count on your hands and your feet. 1, 2, 3, 4, 5, 6, and so on. Whole numbers are natural numbers plus zero. That's the only difference. Oh, 0, 1, 2, 3, and so on. Integers are whole numbers plus negatives. They look a little bit like this: -2, -1, 0, 1, and so on. Last but not least, not to be outdone, rational numbers are integers and fractions like -3, 1/2, 5/8, and 14.2. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. Now listen to the drummer. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. Now listen to the drummer. What about 4? It's a natural number, so it's also whole, integer, and rational. What about -2? Integer and rational. What about 1.5? It's just rational. What about 0? It's whole, integer, and rational. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. Now listen to the drummer. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. Now listen to the drummer.
All right, now that we have watched that video, let's go ahead and see where that video was taking us. Okay, let's go ahead and read this introduction here together. Over the summer, Ethan spent a week at an overnight camp. He ended up meeting several friends, and some ended up being people he attends school with this year. On the first day of school, he recognized one of his camp friends in his math class. Other friends that he met at camp live in different states, but they still keep in touch throughout the year. In no particular order, the headings below describe the different types of friends that Ethan met at camp. Using the graphic organizer below, see if you can place each of the headings in the box where they belong. So, as you can see here, this entire box represents the friends from camp that Ethan met. Okay, all of this right here represents the friends from camp. Now, Ethan could have met some friends from camp from the same state, from the same class, from out of state, from the same city, and from the same school. So think about it. When you go to camp, you usually go to camp with people you know from the same school or the same city. Okay. And when you go to camp, you meet people that may be from out of state or even the same state, but they don't have to be in the same class or in the same city. Okay. So think about how these categories here should go over on this graphic organizer. Okay. So you can start with in the middle, be in the same class and I'll go to camp. Okay. But think about it. If you are in my class at Wedgewood Middle School and I take you to camp, it is possible for other teachers from Wedgewood Middle School to take some students uh, to camp also. Okay. So same school comes next. Okay. You can be in the same class and go to the same school. That is very true. Okay. Now, if you are in the same school and so for example, you all go to Wedgewood and Wedgewood is in the city of Fort Worth. Okay. Now, if you go to the same school, you don't go to a different school at the same time. So you can be in the same city, but go to a different school. Okay. So you can be in the same class. If you are in the same class, you go to the same school. And if you go to the same school, you go to the same, or you are from the same city. Okay. Now, if you all live in the city of Fort Worth, you also live in the same state as other people that live in the city of Fort Worth. Okay. So if you live near Hewlin Mall, okay, you live in the same city as somebody who lives near, um, let's say, for example, Wedgewood Middle School. Okay. So you live in the same city. So that means that you are from the same state. Now, when you look at out of state, okay, you cannot live in Texas and live in California at the same time at this 1 minute right now, right? You cannot be in Texas and be in California at the same exact time. So out of state is going to be over here, okay? California and Texas are two different states, and those two don't belong in the same category. Now, all of these people here could have gone to the same camp. Okay, you could have gone to the same camp, even if you are from out of state. So all of these people here are the possibilities. Sorry, all of these places are all the possibilities where Ethan could have friends at from in the same camp. Okay. All right, guys. Now that we have organized the graphic organizer with all the titles, we are going to have these two questions here. So it's question number one. Is it possible for a friend in the same class to go to a different school? Explain. And then question number two, is it possible for a friend in the same state to go to a different school? Explain. Go ahead and hit pause on this video and answer those two questions in your Google Slides form in Google Classroom. Okay, now that you have answered those two questions in your notes, we have these two definitions here. We need to talk about what a terminating decimal is and what a repeating decimal is. So for example, the definition for a terminating decimal is a decimal number that has a set number of digits behind the decimal point. So some examples can include the number 0.25, 0.5, or 5/10, 0.62, or 6200ths. Can include a number that has three digits behind the decimal, so 0.975 or 975 thousandths. Okay. Can also include numbers that have a whole number, and then we add a digit to it behind the decimal, okay, making that a rational number. So 12.4 or 12 and 4 tenths can be a negative, so negative 2.2 or negative 2 and 2 tenths. We can have this number, as many zeros as you want, 0.2, okay, terminating decimal. Okay, there's a set number of digits behind the decimal point. Now, the repeating decimals. Okay, repeating decimals have a repeating decimal has a digit that repeats a digit or a set of digits, sorry, that repeats behind the decimal. So, some examples include 0.33333 and so on, 0.242424, okay? Or it can be, for example, 4.7777 forever, okay? Notice how these numbers here have one digit or a set of digits that repeats. Okay, those are called repeating decimals. Now, we can also have a number that's, for example, 8.3444444 forever. Okay, notice how that 4 repeats. Now, when you have a repeating decimal, remember that you need to write that number with a line above the number or the set of numbers that repeats. So, for example, 0.3333 forever, you're going to write 0.3 with the bar notation above the 3. For 0.242424, you are going to write the 0.24, but with the bar notation above the 24. For the last one, 8.3444, you're only going to write the bar notation above the 4 and not the 3, because the 4 is the only number that repeats. All right, now let's move on to task number 2. It says read through the types of real numbers in the table below. Give a few examples of each. So as we watched in the video, we had the definitions in the video for natural, whole, integer, and rational. Here you're also going to see irrational numbers. I are rational, okay? So let's go ahead and start off with natural numbers. Remember, natural numbers are the set of all positive counting numbers, numbers on a number line starting with 1. Think about natural numbers as you learn when you are a baby trying to count, okay? When somebody is trying to teach you how to count, you start at the number 1, okay? So this is where natural numbers come in. So right here we have 1, 2, 3, 4, and so on, okay? Those are called natural numbers. Whole numbers are the set of all positive counting numbers starting with 0, okay? So the only difference between a natural number and a whole number now is 0. So 0, 1, 2, 3, 4, and so on, okay? The only difference here again is just 0. Integers, okay? The set of whole numbers and their opposites. So if you're looking at these whole numbers here, you have 0, 1, 2, 3, 4, and so on. Now, the opposites are also going to be in the set of integers, okay? So, for example, we have -4, -3, -2, -1, 0. 0 does not have an opposite, so we're only going to list 0 once. 1, 2, 3, and so on, okay? So that is the set of integers right there. Now, rational numbers, numbers that can be written as fractions, terminating decimals and repeating decimals and perfect squares. Okay, so for example, the number 2/3, okay, can be written as a fraction. The number 4/5 can also be written as a fraction. Now the number 10.5, okay, 10.5 is a decimal, but 10.5 can be rewritten as a fraction as 10 1/2. Okay, so that is a way we can rewrite that. Now, if we have a percentage like 75%, we can rewrite that as a decimal as 0.75, or we can rewrite that as a fraction as 75 hundredths. Okay, 75 hundredths can be reduced to 3/4. Okay, so that is all these different ways that we can rewrite this this number 75%. Okay, now perfect squares. Okay, so for example, if we have the square root of 4, the square root of 4 is 2. Okay, and 2 is a perfect square. Sorry, 4 is a perfect square. So we say the square root of 4 is 2, and that is perfect because 2 does not have a decimal behind it. Okay, um, we will learn more about squares and perfect squares later on. But for now, think about rational numbers as a decimal, fraction, or percentage that all can be written as a fraction in simplest form. Okay. Now, irrational numbers. Irrational numbers are numbers that cannot be written as fractions. So these are numbers for that have a decimal with digits that don't repeat and don't terminate, okay, or don't terminate. So for example, the number pi, okay, pi we mostly know it as 3.14, but pi goes on forever and ever and ever. Okay, so we have this number here is pi 3.14159,265, and this number does not repeat or does not terminate behind that digit. I mean, behind that decimal point. Okay. So also, if we find the square root of 2, for example, the square root of 2 is not going to be a perfect square. So we will learn more about that in the coming lessons. All right, guys. Now that we have finished those notes here, you have a little note on the side here where it says copy slide number 6 and paste it in your digital interactive notebook on slide number 4. So please go ahead and click on the slide here. Okay, this is actually slide number 7. It's not slide number 6. Go ahead and click copy, and then you're going to take this over to your interactive notebook and paste it in on slide number 4. Okay, slide number 4 is already labeled for you in your table of contents, so just go ahead and paste it there, and let's move along. All right, so here we have task number 3. It says place the headings for each type of real number in the graphic organizer below, then see if you can correctly place each of the following values into the box where they belong. Okay, so we're going to go ahead and start with the first definition that we learned here. Okay, natural numbers. Natural numbers are numbers that you start with that start with number 1. Okay, so let me see here. All right, natural numbers are numbers that start with number 1. Make sure that stays back there. Okay, now the next definition that comes after is whole numbers. Okay, whole numbers start with number 0, but it also includes the numbers 1 through infinity. Okay, next we have integers. Integers go there. rational comes next, okay? And then over here, numbers that don't belong together over there on the left hand side are called irrational numbers, okay? And all of these numbers here, or all of these definitions, fall under the real number system, which is this entire system here, okay? Now, your task here is to make sure that these numbers make it in the correct section here, okay? Go ahead and hit pause right now and go ahead and take the time to put these numbers here over where they belong in the graphic organizer. All right, now that you are back, let's go ahead and make sure that you have placed these numbers in the correct place. So negative 12.2, negative 12.2 is a rational number because it has a decimal, okay? Now, number 0 is a whole number because that is the first place where 0 fits, okay? That's the first place where we saw 0 in our definitions. Next, we have negative 15. Negative 15 is an integer because it is a negative whole number, okay? It has no decimals, but it is negative. Now, the square root of 75, the square root of 75 is going to be a non-perfect square. So non-perfect squares are going to be irrational right over here, okay? Now, 16 over 4. 16 over 4 is a fraction. But if we divide 16 by 4, we get the number 4. The number 4 is a natural number. And so we're going to put this fraction, even though it looks like a fraction, when we reduce that, it is the number 4, and it is a natural number. Now, 2 times the square root of 64. When we find the square root of 64, that is 8. 2 times 8 is 16. So 16 will be a natural number there. Okay? Now, over here, again, you have this note here with your interactive notebook. It says copy slide number 8 and paste it in your digital interactive notebook on slide number 5. This is going to be your 5th page in your interactive notebook. Update your table of contents and name it the real number system. Okay, so now it is your turn to answer some questions on slides numbers 10, 11, 12, and 13. This is where your grade is going to be coming from. So make sure that you complete slides number 10, 11, 12, and 13. And when you are finished, make sure you click Mark as Done in Google Classroom so that I may grade your work. Thank you for watching. If you have any questions, please email me or join the Google Meet during office hours from 1:30 to 2:30, Monday through Friday.